My name is Moore. My presentation is on the psychological aspect of migraines. To start with a bit of context, migraines are neurological disorders that include pain, can include nausea, light, and/or sound sensitivity, and can last up to a few days. These are biological effects migraines have, but I want to know the psychological effects. The research method that we covered in class was transcranial magnetic stimulation. The results of the study were that after evoking trigeminothalamic activity to measure CSD, the TMS stimulation was used on 80 rats and 8 cats. The TMS significantly inhibited the CSD from acting in 5 of 9 rats when they applied the TMS just after evoking the trigeminothalamic neurons. In my first research article, I looked at migraines with a neuroanatomical lens. What I found was that a few regions of the brain are active in psychological ways during a migraine. The insula serves as a critical relay for autonomic, emotional, and cognitive changes. These changes are results of migraines. They also found that gray matter volume loss in those with migraine localized to a common brain network defined by connectivity to the visual cortex, an area heavily involved with the process of migraine. The next approach I chose was a systems approach. The visual cortex was found to have increased activity associated with light during a migraine. One of the studies looked at the visual cortex and determined that connectivity to the visual cortex V3A region was significant, showing that the visual cortex was specifically active due to the migraine, and this was significantly different from the no migraine and episodic migraine groups. This means that the chronic migraine group had the most active visual cortex. Next, both the thalamus and the ACC are engaged during spontaneous migraine attacks and exhibit atypical functional connectivity in chronic migraine. The ACC is the anterior cingulate cortex, and put simply, this is involved in emotion processing and regulation. The third bullet point is cortical spreading depression is the rapid neuronal depolarization, and it is the main factor in aura that can occur along with migraines. There is migraine with and without aura. Aura is described as including numbness or pins and needles, unilateral weakness, visual or auditory hallucination, and vertigo. This creates a nice transition to the last approach I chose. The first finding from the epigenetics approach is that DNA methylation is linked to whether or not migraines become chronic, and the methylation is affected by CSD in rats. CSD has epigenetic influence over whether certain migraine genes are expressed. As the author of the article writes, it is convincing that increased neuron activity as observed during CSD and migraine alters the brain epigenome, which consequently causes migraine attack. Secondly, dietary cues influence migraine phases by altering serotonin and norepinephrine release, producing vasodilation or stimulating the brainstem, trigeminal ganglia, and cortical neural pathways. Serotonin pathways, stress hormones, inflammatory mediators, and nutritional substances, which are related to the gut-brain axis, are said to influence variants of migraine. These are epigenetic relationships as they influence migraines, and migraines have psychological effects that in return influence these factors. Thank you for listening.